Thank you very much for coming today, folks. My name is Federico, and today we're going to talk about software supply chain security. So I work for Obscuro. We're a Canadian AWS consultancy working in the software security space, in the architecture space as well. My experiences comes from work with large regulated enterprises and helping them building solutions. So before we start, kind of like warming up everybody here, I want to ask a few questions to everyone. Has anybody ever heard of software supply chain security? Can you raise your hands? Lots of people. Okay, who has done work on software supply chain security? Few people? Okay, let's just like one level deeper. So we're going on. Who has used Salsa or some of the frameworks around SBOM as well? Some hands. A few people. All right, good stuff. Who's like from Malmo here today? Random question? More people. All right, perfect. So you're listening, you're paying attention. Awesome. So this talk is an intermediate plus level talk. Is not super deep on a specific technology, but has lots of breadth. So we're going to talk about several things. If I skim through things too quickly or if I don't cover something, feel free to grab me at the end as well. There are a few times in the talk where I'm going to ask some random questions to everybody, so you can pitch in as well and tell me your ideas there. So first of all, just setting the ground, why are we talking about software supply chain security today? Mostly because the world is talking about it. Like we've seen this with a number of attacks over the past few years. I think that the peak was definitely 2022 and 2023 as well in terms of attention, like media attention to it. But we're seeing definitely an explosion of threats, we will see together today, and also systems and solutions to prevent this. We'll try to frame it as well, because what is happening in the industry today is regulation. Regulation is a super, super big topic right now, and has been going on all over the globe. So you'll see that if you think about like software development and how free-form has been over the years. This is not true in lots of other disciplines where you have controls, where you have academies, where you have lots of things happening. Regulation right now is just coming in on software supply chain security, both in Europe as well as the US, Canada, North America, as well as NATO. So NATO is coming up like with security regulations as well with May 2022. So if you're having like NATO talking about it, I think it's really important to frame this because it's a significant attack factor right now and is being perceived as really critical for the infrastructure. So we're looking at this from a compliance security perspective, but we're also conscious of the fact that good supply chain security, software supply chain security, means that you're more likely to be successful in your software development practices. So the State of DevOps report back in 2022 was already tying companies' revenue with security best practices, which if you think about it, is kind of obvious, right? If you're a company doing well in terms of security, it means that you're more likely to do well in terms of software development, and so you're more likely to make more money as a company. But there's a clear connection there. Okay, so this is the framework. This is the place where we are right now. First question now. Who has heard of the Solarwinds attack of 2022? Lots of people. Okay, can I get some feeling now on a 1 to 10 scale? Who would say is a high risk of attack for a company? Who would say is a low attack risk? High, raise your hand, I would say. Okay, like 10, 20% of the audience. So most people think it's a low risk attack. Second question, level of complexity of this attack. How complex was it? Was it like really easy for the attacker to do this or really, really complex? Who thinks is really, really complex? Can you raise your hand? Okay, you think it was easy for the attacker to perform SolarWinds? Hands? Yeah, more people. Perfect. So let's see, let's play it back together. So SolarWinds is actually very complex. Let me tell you how it works. So this type of attack, the way in which it was working is that some attackers, still unknown today, believed probably to be Russians, but not clear right now. They managed to enter Solarwinds and compromise their supply chain security for an application called Orion. So they entered the CI/CD pipeline for Orion, added more code onto the application itself, then use the software update system of the application to deliver this payload with the application itself onto the final end customer, final consumer. So you would download this as a signed executable as part of a normal update process. Okay, the application is signed and stays silent for 14 days before performing actions. So you're downloading this then does nothing for 14 days, then starts executing actions, and there's a complex logic on which platform is actually running, because this, behind the scenes, is a targeted attack. You're not doing this because you're just like pointing at all SolarWinds customers. You're pointing to certain SolarWinds customer. And it's called what is called an APT, is an advanced persistent threat. The interesting thing for me about this thing is like you're deploying something and stays silent for 14 days before doing anything. Think about the detection of all this and how much logic has been behind the scenes. Okay, let's go to a next one. Log4j. Sure that December 2021, lots of you have heard it. Vulnerability in the Java on a part of a Java library called Log4j. What is interesting about this is that this is clear RC, so this is remote code execution. If you were using the library under some circumstances, an external attacker could come in, trigger some logs on your application, and then this library would execute action on your behalf. So it was super widespread. But the reality is that as of today, we don't really know how many applications, how many organizations were affected. So super widespread, but who's actually using the library in that way that exposes you to vulnerability, which is part of the problem, right? So oftentimes you're looking at these vulnerabilities and they tell you, oh, this is high risk for your library. But if you're not using the library in this way or the other way, how do you know if it's actually a risk or not? Let's continue our journey with something that goes on to social engineering as well, to an extent. So who has heard of brandjack, this expression here? Brandjack is something also called typo squatting. So the idea here is I have on NPM, I have a very commonly used library called Browserify, with NPM being, by the way, nodes, a dependency management system. So I have Browserify. What people have done is to create a library with a very similar name, web-browserify. And if you're downloading the wrong library, importing the wrong library in your system, this library starts doing things, right? So for example, this library starts to scan for credit card numbers on your laptop or personal information on your laptop and extract data as soon as you're running it. So this is a clever way of doing it. There's not much, like, if you think about it, there's not technical complexity about this. It's just finding the right name. But if you're importing the right library, the wrong library, you're importing problems to you. 1.3 million weekly download before they took it down. Okay, so this is a very popular thing. Browserify, brandjack, as we said. But this is not only it, and this was an attack, right? Malicious attack, somebody uploading a library on NPM. What about if people are just upset? Because it can happen, right? People can get upset. So this is a different type of attack. So allegedly, the author of an open source package really upset with the monetization or lack of monetization of his own open source package and the enormous pressures that he was feeling from the community and the people there. What they did was, okay, he's got really upset and he changed his own library to cause a denial of service of the application that was using the library. So that's a different thing. This is not an attacker now. This is a reputable library that you're using where the maintainer gets upset about open source and says, okay, there are millions of downloads of this library here, and people are like making money with this, but I'm making nothing out of it, and I've done all of this development for it. So people get upset, and it's a risk for the organization. There's more in our journey of types of attacks. PyTorch namespace confusion. So PyTorch is a super popular ML library. In this case, what happened? Well, okay, so this is a bit more complex, but there's a CI/CD pipeline happening here that is building PyTorch for the library itself, right? And then you as a user, you download PyTorch. This library, this CI/CD pipeline was fetching a library as part of the build process. And what the attackers did there was to register on the package manager an updated version of the library. Because PyTorch was pulling in latest, effectively downloading an updated version of the library. This is less of a problem on PyTorch. It's like PyTorch was sort of like doing it right to an extent, and more of a problem for the dependency management tool that Python was using at the time that would allow anybody to register any libraries with an updated version of the library itself. So this is another significant risk that is a different type of risk, but it's still pretty significant and is affecting lots of people. Now, let's go to the most recent one. Okay, who has heard of the SSH vulnerability connected to a library called xzutils? A few people, right? Quite a lot of people, 30%. Okay. Question, how long do you think the attacker has worked to cause this problem, to perform this attack? How long did it take the attacker to do it? Ideas, how long did they work for it? A year, okay. More or less? 2 years, 2 years. Okay, let's see. November 2021, we're going through the journey here because I think it's really interesting to tell you kind of like how it works, right? So November 2021, a GitHub user, Gia T75, creates just a GitHub account and starts committing code to a library called xzutils. This library is just one of the many libraries that are part of the Linux ecosystem. It's a compression library for lossless data compression. So it's a really cool library. You can use it. So November 2021, first commit, genuine commit, just improving the library. Hi, I really love open source. I really believe in open source. Here are my comments. Perfect, pull request, merge, everybody's happy. March 2022, this user starts engaging with the community and starts saying, hey, the development of this library is too slow. I can do more. I can contribute more. Let me help. Let me help. At the same time, what happens is that some other users, GitHub users, who seem to have been created just for the purpose of applying more pressure on the maintainers of the libraries, start sending more messages and start spamming the maintainer of the libraries saying, hey, why is this library so slow at developing new features? Why are you so slow, maintainer? Why are you doing this slow open source work? Let us help you, let us help you. Let Gia T75 help you. And so what happens is that a year down, January 2023, this is happening. June 2023, Gia starts embedding himself into the library and becoming a maintainer of this library as well. And he starts to do the first commits. The first commits are still available on GitHub, so you can go and check them out. They're targeting the testing infrastructure that the fuzzing Google open source library or project does of the library itself. So what he's doing right now is that he's changing the tooling that is detecting the behavior of the library. The fuzzing tool is detecting that. June 2023. Okay. Journey continues, and there's also a link to a very interesting blog post that explains kind of like what I'm talking about now. February 2024. So from November 2021, all of this social engineering work until February 2024, when Gia says, okay, embedding the backdoor in the library, okay? Turns out that this library is not any libraries. This is part of OpenSSH, okay? So OpenSSH uses the library at runtime on people's laptop and servers and systems. It is a month and a half later, March 2029, when completely by chance, a Microsoft developer detects that there are some performance concerns with this SSH library that are connected to this compression library and says, okay, this is weird. Why is it happening? okay? And then this starts going on and becomes a big thing we're all aware of, and then patching and everything there. Just to point out, the actual payload is a 4-stages process that includes extraction, bash scripts, and hooking of SSH functions. The hooking of SSH function that is not detected by the fuzzing library because GI has also changed the fuzzing library that was detected in this, right, in the pipelines. So it is really interesting. Is it the library that is at the forefront of development and security, but it's not using itself, and a clear advanced attacker took them 2 years, 3 years of work just to get the backdoor in. So very interesting combination and how much effort has been put there. This is a clear advanced persistent threat as well, which is there for a number of reasons, and we'll talk about it. Okay, let's go with the last one as well. I hope I have entertained you a bit with like this journey on security risk. Like, but I have a last one. Who has used LLMs here? Everybody, right? 99.9% of people. Perfect. Okay, who has gone and asked an LLM, hey, can you create an application for me? Can you write this piece of code for me? How many people? Yeah, 40%. Okay. What happens if you do it, right? You go there, you say, can you write this piece of code for me? And the LLM says, okay, here is your solution, set of libraries on top, and then the source code, right? What happens sometimes is that the libraries that the LLM is generating for you are don't exist. They're hallucinating. The LLM generates an hallucination and says, okay, import these 4 libraries, 3 exist, 1 doesn't exist. Now, what is the problem with that? The problem is that if I go and I ask the LLM, do it for me, the LLM will create this library, will generate this response with 3 libraries and an hallucinating one. Then somebody else, let's say that person over there, goes and asks the LLM the same question. The LLM once again prompts a response with different libraries, but once again, one is hallucinating. Then somebody else goes there again and says, hey, LLM, generate a different application. Generate, I don't know, like a mobile application for me. Once again, the LLM prompts 4 libraries of response. 1 is hallucination. What is the trick there? What is the problem there? Is that the LLM hallucinates in statistically repeatable ways. It means that the LLM tells everybody, use this library that doesn't exist. But what if I go and I create the library on GitHub? Now, somebody else will go to the LLM again and say, okay, I'm going to import this library, but the library now exists. It's just that the library is actually a malicious library now. So you're importing a malicious library that didn't exist before because the LLM told you you have to use it. Very interesting. So it's about this clever way of detecting this. Security researchers that are linked here, they have been doing work on this, and they were really good at embedding this process, and they were able to see through a POC that in 3 months, a fake empty package got more than 30,000 downloads, including downloads from FTSE 200 companies, so like very big enterprises there. So this is interesting, right? It's a clever new type of attack on open source hallucination and packages there. The big problem that we've seen is that we have 1, 2, 3, 4, 5 different classes of attacks. So how do you solve all these problems at once? How do you do it all together? And this is where it gets interesting. So we have to focus the problem, first of all. The big problem that we haven't tackled directly right now is what we're starting to realize as an industry right now, which is open source maintainers are not suppliers. This is the crux of the issue. The problem with software security supply chain is the fact that we as a community, we've built an ecosystem based on open source that is now really the underpinning of lots of almost every application out there is using open source technology. And open source is mostly run by people who are not paid. And because they're not paid, or because the industry is not giving back to those people, then you see all of these types of problems. And the solution that the industry is adopting, by the way, very interesting, is not, if you think about it, is not actually contributing as much back to open source, but generating an ecosystem of companies that are trying to secure open source after you're importing it, right, in your system. So you're not contributing back and making sure that you're building it right. You're using software that secures open source adoption. But the crux is this is the problem. Open source maintainers are not software suppliers. There's no contract between you and the open source maintainer, even if everybody is using them. The second part of the problem is that attackers have figured it out. Criminals have figured it out by far right now that this problem is there. There are no doubts in 2024 that everybody has figured it out, and there has been a journey around this, right? But as we've seen lots of different types of attacks, and we've seen and realized that software supply chain, the supply chain that takes me from here where I am today with here is my application to the original library that was coming at, is very long, and is not just about the software itself, okay? It is much broader than just the source code. It is bigger than the CI/CD pipelines. It is bigger than dependency, storage, patch management, all of this. What is it all about? It's all about the people who contribute to the code. So we're going to focus about technology in my talk right now. So we're going to go into the tech right now in a moment. But what I want to stress before we get there is that this is not just about technology. Securing open source and securing your supply chain means physical access policies, means developer training for your application, means outsourcing policies, right? Means procurement, means that, for example, right now, if you want to supply software to the government in the US, you have to have not only certain certifications, but certain assurances about the software open source that you're using as part of your application. So all of this is a journey, and we're getting there. But the solution to the evil developer problem is not only PR checks, but background checks. This is very much physical security and real security as much as code and software. So the industry said, hey guys, nothing to worry about. We're going to come up with some ideas to help you doing this. We're going to come up with some frameworks. Different software suppliers, different solutions. Some frameworks focus on open source, some others, and the CNCF is there for open source. NIST in the US is a more broad framework. CIS frameworks, Microsoft, so many other things happening as well. The most commonly known one is called SLSA, SLSA, is a framework that is an acronym that stands for Supply Chain Levels for Software Artifacts. And is a framework, a checklist of standards and controls that you can apply to your source code to become SLSA compliant, meaning that you're following best practices as part of the process to develop your application. SLSA spun out of Google, unsurprisingly, and is really targeted at reducing the risk of using external resources for your applications. Okay, so these frameworks are super long. They are hundreds and hundreds of pages. So how does developers know about this? Well, here at the core of the talk, we're focusing right now on what we can do to help solving the problems we looked at. So we're going to go through the journey, technically going through the journey. We'll cover lots of ground. Feel free to stop me or ask questions if you're just like going too fast about this. But the first part of the process is source code, okay? I am a developer. I'm developing my application. I'm importing some libraries. There are two libraries with very similar names. Which one should I import? Which one is a reputable one? And, there you go. And the open source, OpenSSF with scorecards are really, really important in this sense. So we're starting now to see that lots of open source projects are adopting the scorecards that will tell you, okay, if the application has reached a 10 out of 10 as part of their scoring, it means that it's following all security best practices. If the application has a 2 out of 10, that is not following security best practices. So you can use these scorecards that you will see on lots of open source projects to inform you on which one is the best one. At the same time, specific vendors, Google being one, they're coming up with verified software supply chain security solutions. So verified libraries. This library I can use, this library is recommended for you to adopt. It's really interesting as well. How do the scorecards look like? The scorecards look like this, right? So there's a scoring if the open source application is using software fuzzing or binary artifacts or is using branch protection, they get a score. The higher the score, the more secure the library you're importing. As you can see, this is the Sonatype average for 2023. The average across open source is still pretty low. Okay, so there, for example, almost nobody does fuzzy testing as well, mostly because it's expensive to run on each open source, merge or fuzzy testing. So there is still definitely a journey we're going there, and the average is pretty low, but we're going in the right direction. Then, when importing open source libraries, we're using security and dynamic code analysis tool, source code analysis tool. You're importing them, they run against the libraries themselves, and they can tell you, okay, this library is having a strange behavior here, or is maybe importing something strange that we're seeing. The problem with this is that it is really hard, as I said before, to prove that a risk for the library is a risk for the application that you're using. There are commercial solutions right now out there that will help you with this. So some commercial solutions right now will tell you you're not only importing this library, but you're also using this part of the library, and as a result, you really are susceptible for this vulnerability. But if you're not importing, if you're just importing the library, but you're not using that part where the vulnerability is, you're not at risk. But open source doesn't have that. In the same way, there are no tools right now in the open source that I'm aware of, but tell me if you know of one, that will protect you from the dependency confusion, from I'm importing a library with a similar name, but cannot help me there. So semantic versioning, hashing, all of this can help at preventing you from making mistakes, but think about software, source code analysis tool and dynamic code analysis tool, and thinking about the fact that if you want to spend a bit more money, there are commercial vendors that will help you effectively telling you this library is a risk or is not a risk, as you're depending on how you're using it. Then the other thing, if you want to protect yourself from open source maintainers that sometimes upset or for whatever reasons delete the repos online and stop you from rebuilding the application, you have to have an internal mirror as well. Protects you also from external downtimes as well. So internal mirrors, there are all sorts of variations. There are commercial ones, JFrog, Artifactory, Sonatype as well. There are Harbor, which is a CNCF project, so you have open source and commercial options. The other thing to think about is not to import the binary unless you have to, but importing the source code. So where you're compiling it yourself, so you know what you're importing it as well. The other thing is the evolution of the industry, right? So we're looking at vulnerability disclosure reports, right? The VDRs. Now, vulnerability disclosure reports is something that is really important. So if you're this will become, I suspect, more and more requirements for a company, right? So when you're supplying a new version of the application to the government, to maybe a large organization, you'll need to supply also this report that tells them, here is how we've used open source as part of our application. Here's how we made sure that we're using open source in a compliant and secure way. Okay, so we talked about some source risk. The other risk, or the other thing I want to talk about is software bill of materials, SBOMs. Who's using SBOMs as part of their development processes? A few people, right? So you're mostly familiar with it. SBOM. What is an SBOM? It is a list of all the libraries and all the systems you're importing as part of your application. When building containers, oftentimes SBOMs are a list of the components of your container as well. So SBOMs are really useful because you can certify the content, you can verify the content, and also critically, you can apply policies at the organization level that say, we're only allowing libraries in our application, in our organization to go to production that have a CVE, that have a risk lower than XY, right? So SBOM is super important. Generating SBOM is really is really the forefront of this security process. Not only that, we have some controls around this. We have RBAC on our branches. We have build policies. We have SSH keys to access repositories as well, to make sure that when we're committing code, we are the people who say they're committing code. But really, if there is an important takeaway, SBOM is the one that really helps you defining this and protecting from lots of critical things. Then AI. So 2023 paper about AI and having AI writing code. So perhaps unsurprisingly, but first of all, AI assistants statistically write significantly less secure code than humans. Nobody's surprised about this, I think. Second thing, but it's more interesting, people that are using AI assistants to write their code are more likely to believe they wrote secure code, even if it wasn't, suggesting that people are overconfident about their security posture. So AI assistants, super useful, we all know this, but they have to be used consciously, right? So you don't want to just use them, import them, as they are today. The trick here is to look at an AI assistant with the same risk profile of open source. The code that the AI is giving you is an open source, it's coming from open source, right? So you're using software static analysis on it. You're not just importing as it is today. We're thinking about package hallucination and a whole category of LLM-specific risks. These are coming up right now. They're not defined yet, so I don't have it in my talk, but thinking about poisoning the behavior of the LLM in generating then responses that trick developers into importing source code or have source code behaving in a way you don't want it to behave. So changing the behavior of the LLM is just very interesting. Not to mention all the risk with importing, as people are doing now, models from Hugging Face in binary formats that are just not only models, but there is a model plus a binary that steals your credit card information, right? On top of this, you have LLM-specific risk. Okay, so we're going into build phase now. We have our build phase. We've built our source code. We're building our source code. We have secure source code. How do we make it secure? Well, first of all, we want to use immutable builds. We want to make sure that when we're building an artifact, then this artifact is one, and we're promoting this across the environment. You're not rebuilding for staging, rebuilding for production. You're building it once, and you're promoting across. Each time you're building as well, you're building on ephemeral secure workers. The workers you're building on, you know exactly what is running on them. We want to protect ourselves from the Solarwinds supply chain, right, risk. There, you want to treat your workers as production. You don't want to have your workers in a less secure environment. You want to have your workers in dev. You want to have your workers with the same risk profile of production because they are effectively the same thing. And we want to have then maturity about this. We want to have is rather than having developers either being too lax or too strict, or even the security team of the organization being really strict and saying, you cannot use open source, or being too lax saying, import whatever you want. As a company, we want to come up with enterprise policies that say, during our build process, we have to adopt open source in this manner. We have a company policy, an organizational policy that says this. And then we have to establish provenance. Now, provenance, what is it? Provenance exactly. It's a bit of a specific term to the supply chain security and is a way of saying, okay, is an attestation that the builder produced the subject software artifacts through the execution of a build definition. So it's a way of saying, when we're building our building process here, we're building as we told you we would have. It's a fact that is a JSON in the end that is verifiable. So it's a JSON that you can say, okay, I follow this process to build my application and I have established provenance. Provenance is mentioned in almost all the security frameworks, but SALSA has really its primary security framework establishing it. So, okay, as we said, establishing provenance, using reproducible builds as well, validating all the artifacts that we're using, signing the artifacts, using dedicated storage repository, and critically, like I've seen this happening so many times in company, stopping the build on failures. So many times company will say, oh, our tests are flaky, so whatever, continue the build if it fails. Or companies are saying our tests are incomplete, so continue on failure. No, stop the build on failure. Phase 3 after this, we've built, we're sure that the application is compliant. What are we doing? We are deploying it. So when we're deploying it, what we're doing? Well, let's just say that we're deploying on a modern stack like Kubernetes. How am I saying? Okay, if you're deploying a container in Kubernetes, as an organization, I want to establish policies that say we're only accepting signed images on our clusters. We're only accepting images that have provenance established on our clusters. And we're doing this at the platform level as the organization where we're coming in and having this. And I want to make sure that these policies are enforced. There's a whole new set of tooling in the open source world. Open Policy Agent and Kyverno are really used for this to validate this behavior. And after that is not over, because after you're deploying it, you're getting into updating. How do you update it and when do you update it? Okay, so 20% of the open source packages or libraries or projects that were maintained in 2022 are not maintained today. So open source decays by 20% each year. 96% of vulnerable downloaded releases has a fixed version available. So people are deploying and then leaving it there because it runs, and nobody thinks about updating the applications, whether there should definitely be a update policy there that says not only you're running our application here, but we as an organization, we establish a policy as a platform team. We say that we're going to remove your pods, we're going to remove your deployments if your application decays in security score. So this is really important, as well as having continuous analysis of the software deployed as the source code deployed there. So you have this container in the container world, runtime, vulnerability scanning, but malware there. So the big takeaway of this session is that you have to establish a corporate supply chain security program. So as a company, we decide here is our posture as a CTO, as a tech lead, a front end, back end teams. Not only security, this is not a security concern, this is very much also a security concern. This is an entire organization that thinks about this. So who does this? Who in company establishes this type of programs? Good question. Who are you going to call? Ghostbusters? Not Ghostbusters. But you're going to call a platform team that you're building, right? The platform team, this organization there, should protect you from a significant risk. The risk of using the best tool to solve the problems. If there are 10 teams and everybody chooses their own technologies, their own systems, this becomes really, really cumbersome for the organization to then maintain, keep up to date, and ensuring that all of these systems adopt their security posture, security policies. So we're building platform teams. Lots of you will have platform teams today. Who here works in a company that does not have a platform team? One. That's very interesting. So almost everybody's got platform teams, right? 90% of people have platform teams. So this is really good adoption. So platform teams, you all know what it is. Glue, specialize. The important thing is that your platform team should build a golden path, should build a standardized way for the teams to adopt software, but should also allow you to advocate this and go down on the stack if you want to go down the stack, but then it means that you're taking the maintenance and cost controls there. So I'm not in favor of platform teams that say, oh, we're only doing it one way, our way, nor I'm in favor of people that just do whatever they want, but a good common ground where we're establishing golden paths that simplify adoption, simplify processes, but allow you to get there without making too many mistakes is really good. But if you're really modern, if you're really experienced, and you want to run your own code and you want to run it in your ways, you should be able to do so while making sure the company has standard practices. So coming to the end of the talk, what are the takeaways? Takeaways, what do you need to remember about software supply chain security at the end of the session? So number one, This is a company thing. It's not some person doing it in a corner. We as a company, we should establish a platform engineering, a set of policies that are part of this, that help us protect this. The second takeaway is the fact that open source in 2024 is not open source in 2014, nor open source in 2004. We've realized that the crux of the issue is that people are treating open source as a supplier, as a vendor, whether it's just a maintainer open source, and this dynamic creates problems, and we need to have a mature open source culture within the organization. We're using this there. We've also realized that there's a clear ROI between using secure software supply chain security and adopting these practices and generating revenue for the company. It's not about security, it's not about compliance, it's about how we can make more money for the company by doing the right thing, establishing the practices. So this was my talk, finished on time, so thank you for coming, folks.